right? The second one. Okay, so this one, we are given gx equals to 2x minus 3. Hx is given by x squared plus 7x minus 3. So we need to find the g inverse. Well, there are two ways we can do. We can do like this. For A, or you want to find the g inverse generally also can. If you don't want to find the general part, you let, okay, never mind, we have gx equals to 2x minus 3. So now we want to find g inverse 5, right? So basically, if I bring this one over, okay, then it will be g inverse. Do you understand? That means like this. It means you let the things that you want to find, let y equals to g inverse 5. Therefore, the function g you bring over like this. Understand? Then do you have function g? Yes, we do. It is 2x minus 3, but just that it's not x, it's y. Yes, 2y minus 3 equals to 5. So 2y will equals to 8, y will equals to 4. So you get the answer right away. What is y? Y is g inverse 5. Therefore,
g inverse 5 is 4.
Okay, so this is one of the way. All right, now B, HGX. Okay, this is the one that we need to find, HGX.
Teacher, is there a way where you can find what g inverse?
Sorry, which one? You mean this one?
Find, yeah, g
the inverse, huh? Okay, if we were to find the G inverse method, yeah. Okay, let me. Okay, if you want to find the G inverse first, okay, G inverse. G inverse is the thing that you want to find, right? So always let Y be the G inverse. And then bring the G inverse over. It's the same process. Just that for that process, we substitute with specific value. But for this, we put a general value. So bring this one over, gy equals to x. And what is the function g? The function g is g object minus 3. And our objective is always make y the subject. Okay, so once we make y the subject, then you see y is g inverse. Therefore, we got generally g inverse equals to x plus 3 over 2. So our SOP is always this. Okay, you let y be the something that you want, and then try to change it back to something that you have, because I do not have g inverse, but I have gx. So I change it so that it come back into our comfort zone, and then substitute accordingly. So this is generally we find the inverse function. All right, then after that we substitute specific value, we get the answer also, like that. Okay.
Okay.
Now next, okay, the next part will be, okay, what did I do? Oh, I'm going to adjust All right, now next we look at the HGX. HGX stuff. Okay, so over here, what do we do? Always start with the function that has the object. Okay, now I just put the h first. I substitute the gx. Gx is 2x minus 3. I do one thing at a time. I do this. Then now the gx will be the object for my hx. So the hx is, what does the hx say? It says the object square. Always write the framework plus 7 object minus 3. This is what the function h says. Okay, so always write out the framework. Once the framework is correctly copied, now we put in the specific object, which is 2x minus 3. Then expand. Then we will have 4x squared minus 12x plus 9 plus 14x minus 21 minus 3. Understand? So when you are doing this, focus on this 2x minus 3. You expand it using the formula a plus minus b squared. Always use this formula, a squared plus 2ab plus b squared. Okay, if it is minus, then minus here. All right, so the first one squared is 4x squared. This is minus, so 2 times 2 times 3. So 12x. Negative 3 squared is positive 9. Then when we combine the like term together, 4x squared, negative 12x, positive 14, so positive 2x. And then over here we have negative 24. Negative
Minus
24
15.
and 9, negative 15. That's it. Okay. Does the question say find the HGX? Okay. All right. Next. The graph shows the function. Now this is an absolute function. All right. For the domain, so there must be a limit, a boundary. Yeah? Okay. And then we need to find the minimum point of fx. So by looking at this graph, the minimum point is this. So your fx minimum will be, this is your fx. How low can you go? Here. So it's 1. Understand? You boxed up everything. So the part that you boxed up will be the value within this frame. So the x value will be in between negative 2 and 3. And the y value will be from the maximum 9 to 1. Can you see that? All right. So state the range for the given domain. The range of fx. So you see the range of fx from the lowest to the highest. So we write like this. Fx will be in between, because this one equal and greater than and equal to. So the minimum is 1, the maximum is 9. That's it. Any question?
No.
Simple. Okay. Let's see the next part. Number 4. Okay. Given the function 3x minus 2 and 2x over x minus 4, always put on the condition so that this gx is defined. So your x can never be 4, so that at the bottom can never be 0. Yeah. So we need to find this. How? When you see inverse, you got to find
Let
inverse
y.
first. Yeah, correct. Let y be the f inverse that you want, and rearrange y because I have fy. I have fx. So die also I need to use the function f by moving this function to the other side. The inverse of the inverse will be the function itself, and then put in with object y. Our objective is to make y the subject. So minus 2 bring over and then divided by 3. Therefore, f inverse x equals to x plus 2 over 3. Okay, not yet. This is not our final answer yet. We need to use this one to solve A. Okay, therefore, f inverse gx equals to f inverse, one thing at a time, 2x over x minus 4. Okay, now what does f inverse say? It says the object, you plus 2 and you divide by 3. And what is your object? Another fraction. So when you have fraction in fraction, always do like this. So look at the numerator. we try to combine it. So both multiply x minus 4 and x minus 4. Okay? And then over 3 means divide by 3. Huh? Okay, I separate. When you see fraction in fraction, always split them. Otherwise, it looks very messy. So we will have 2x over x minus 4. I'm finding the lowest common multiple, which is x minus 4. And I combine them right away. And up here, it will be, open up bracket if you can. Do it right away. Plus 2x minus 8. Okay, and then we will have 4x minus 8 over x minus 4 times 1 over 3. This one, can we simplify? It doesn't make much difference, yeah? Okay, then we just leave our answer as this. 4x minus 2 over 3x minus 4. Where x can never be... That's it. All right? So that's A. Next, B. Okay, FG inverse. Oh my gosh, we got G inverse some more. Okay, yes?
Andy said he doesn't understand the right part.
Which one? Which one? Huh? How come you never tell me when I tell you?
He was there in the group. He said he smiled and chat.
Oh, okay, okay. I see. All right. He sent to our chat group, is it? I didn't see. Okay. The right part. Which one is the right part? The F inverse GX. This one. This one, is it? Is this the one or the middle one? Okay, the middle one. We found the F inverse, right? So this one, no issue. And then this question, all right? Because I need to use the F inverse, so I got to find it first, which I found it. So now let's work it out. Always start with the function together with the object x. All right? That's why I write like this. I leave the F inverse first. I replace the gx, the 2x over x minus 4, which is this given. So this line, all right? Yeah. Next, I have to use the function of F inverse with the new object. So according to the function F inverse, it is the object plus 2 over 3. My object here is a complicated object, which I don't want to write it first, because I know in exam, right, we will tend to be very nervous, so we will make mistake from there. So what I do is I will take the F inverse, I put down the framework like this. That means object plus 2 divided by 3. Then only I put in the new object. The object here is 2x over x minus 4. Are you okay? Oh, you got it already. So I want to plus this term and this term. Therefore, I need to find the lowest common multiple. That means I multiply x minus 4 up and down. Okay, fraction in fraction, normally I will put the denominator in this way. So it doesn't look complicated. Look neater. Okay, so this is how we get the answer. So no issue, yeah? Next, we go to part B. Part B, we need to use the G inverse. So we still have to use this way. Let Y be G inverse. Then, yeah, and then GY will be X. And G says 2Y over Y minus 4. Always remember our objective is to find Y as our subject. So this one bring upwards to the other side. So we will have 2y equals to x times y minus 4. So we will have xy minus 4x. Let's group all the y together. Now I will bring the 2y the other side and the minus 4x to come there because I prefer without negative. Yeah? So we will have 4x equals to xy minus 2y. Objective is to make y the subject, so filter the y out. factorize. Factorize the y out. We will have x minus 2 equals to 4x. Therefore, y will equals to 4x over x minus 2. And what is y? Because we let y be G inverse, therefore G inverse will be 4x over x minus 2. Not yet, huh? A lot of students do up to here and yes, continue. They forgot to answer the question. The question say f. The question say f. Hey, what happened? Okay. Wait a second. Ah. Too big cannot, too small also cannot. Okay. We want f G inverse 3, right? F G inverse 3. Let's check. Yes, f G inverse 3. So f G inverse 3, now I have function f, I have function G inverse, just use it. Always start with the function with the object. F, just leave it alone first. Substitute G inverse 3. So the G inverse say 4 times object over object minus 2. Okay, this will be the object for our f. So what is our object here? 3. Just put in. Solve whatever inside first. Okay, so 12 over 1. Correct or not? So now we just need to look for f12. And according to function f, it says 3 times object minus 2. So put the object in, 12. So we have 36 minus 2. The answer is 34, like this. Don't try to go and find f, g inverse x like this, and then work out and get the general function like this, and then only you sub in. No. If you can sub in, always sub in first, because we are simplifying the object. When our object is more simplified, we make less careless mistake. So the tips here is such. Unless no choice, we have to put it in x. So we have to work it out until it is in terms of x. If it is number, just sub in and calculate, that's all. Okay? Hannah? All right. So I'm actually reading the WhatsApp at the same time. So Andy, if you have anything you want to ask, you can actually type. Okay, don't have, huh? All right. Now next, number 5. We have quadratic equation and it has 2 distinct roots. The key words is this. It has 2 distinct roots. The rest, no matter how they ask, how they create the question, not important. Look for the keyword, 2 distinct roots to tell you the type of roots. If you have 2 distinct roots, the thing that you need to know is b squared minus 4ac. It is always greater than 0. This is the one that we need to use. Okay, now before we use this one, we have to make sure our equation is written in the form of ax squared plus bx plus c equals to 0. We have to make sure this is it's written in such, then only we can use the a, the b, and the c. Clear? So with that, it is not in the ax squared plus bx plus c form, this general form we call it. So let's expand the bracket. So we will have 2x squared plus 2x equals to px minus 2. Okay, rearrange. 2x squared plus 2x minus px plus 2 equals to 0. Again, we group the like term together. Okay, put the coefficient together. The coefficient for x is 2 minus p, and then plus 2 equals to 0. So isn't it, it's already in the form of ax squared plus bx, plus, must bring along the sign in front of the term, and then plus c. So with that, now we can put this one in here. B squared minus 4ac greater than 0, whereby the b is 2 minus p squared minus 4ac greater than 0. For this one, let me see which one I prefer. Okay, I prefer to do this. 2 minus p squared. Better don't. I think I expand. Let me expand. So 4 minus 4p plus p squared. And then minus 16 greater than 0. And then p squared. It's another quadratic equation. Okay, whenever you see quadratic equation, always write the highest degree in front, followed by the next lower degree, which is minus 4p in this case. And then minus 16 plus 4, that will be minus 12, greater than 0. And then factorize. Always factorize. Once you reach here, always factorize. So we have p and p. How do we get 12? 6 and 2. Because the difference will be 4. Once you reach here, always use the number line or the graph. Because on this line, your y equals to 0. This whole thing is your y. So your p value is either negative 2 or 6. And you want the y value, the whole y value, greater than 0. Isn't it your y greater than 0 is all here? Yeah? Therefore, the p will go this way or that way. So p is either less than negative 2 or p greater than 6. This is the answer for the range of values of p. A lot of times, students, they put their attention on range of values of p. They keep thinking how to find p. They factorize the 2x squared plus 2 minus p. They try to factorize this quadratic equation, which is wrong. You put the wrong focus. The focus is what kind of roots. Equal roots, b squared minus 4ac equals to 0. Distinct roots, b squared minus 4ac greater than 0. It has roots, but it never tells us whether it's 2 distinct or 2 equal. Then it will be b squared minus 4ac greater and equal to 0. When it has no root, then b squared minus 4ac less than 0. Whatever stuff they write at the back or in front, they will eventually come to the final answer.
Sure.
Yes.
B square minus 4ac greater than 0 must be outside the graph, means like on the left side
Yes.
and the right side.
Because yes, it's on the
If less than, then it's in the
less
middle.
than is the middle, yes. Because basically it's the whole thing, y greater than 0. If according to this, this is our x-axis, this is our y-axis. Isn't it the over here y equals to 0? And when you go above, it is y greater than 0. When you go below, is y less than 0. So we are actually looking for this. When it is greater than 0 are all the values here. So the corresponding x value is this one.
If it's equal?
If it is equals, then will be negative, equals to negative 2 and 6. If it is an equation. Equation, no issue. P squared, let's say you do up to here.
If no root, use less than 0.
Yes. This is equation, quadratic equation. Quadratic equation, no issue. You get p equals to 6 or negative 2 right away. But when you have inequality, once you reach here, you must use the curve to find the answer. A lot of students, when they reach here, right, they say, oh, p greater than negative 6 and p greater than negative 2, which is wrong. Not correct.
So if it's only one root?
It's only one root. That means 2 equal roots. No?
Yeah.
When it is only one root, it will be b squared minus 4ac equals to 0.
Okay.
This is called discriminant or determinant. Something along the line. Don't know which is which. Okay. Is it discriminant? I think it's discriminant. You discriminate whether it is. What kind of roots is this? Hang again. All right, now let's look at number 6. We have to form a quadratic equation which has the roots of -5 and 4/3. Give your answer in the form of ax squared plus bx plus c equals to 0. Now you can use the Sopor method. Okay, the Sopor method, or you use this one. Still hanging on. Wait. Wait. Do you still remember the Sopor method?
HTP and HDB.
Yes.
Oh.
Sum of roots and product of roots. What? Hasil tambah dan hasil darab. Yeah. Okay. So this one very easy. It's either you use Sopor or you use a factor of quadratic equation. Let me use that one first. We have, you see, because these are the roots, so x equals to -5 or x equals to 4/3. Therefore, you rewrite, it will be x plus 5 equals to 0, or 3x minus 4 equals to 0. You have two factors, isn't it? You put these two factors together and form equation. So expand. So we will have 3x squared minus 4x plus 15x minus 20 equals to 0. So 3x squared plus 11x minus 20 equals to 0. We got the answer right away. Isn't it when we solve the quadratic equation, we work from here, okay? Then we factorize, and then we get the answer, like that. Correct or not?
Teacher, this question like that done already?
Done already.
Wow.
That's all. Done already.
Teacher, where can get 3 marks?
Okay, the 3 marks. First, you form this one. Okay? It's either I see either this or this 1 mark, and then you put them together, another 1 mark. And then this one, everything correct, 1 mark. So 3 marks altogether. Okay, Andy, just now your question is, in what case do we need to change the direction of the arrow of inequality when we multiply the inequality with negative or divide by negative? For example, I put at the side here, let's say x greater than 4. Sorry, negative x greater than 4. I want x, I don't want negative x. So isn't it I multiply both sides with negative, right? I multiply negative 1 on both sides. Okay, then I will have x less than negative 4. Or you can also say I divide both sides with negative 4, up to us lah. So that is the only only condition. We change the direction of the inequality sign. Okay?
So as long as divide negative or times negative, then change direction.
Correct. Hey, your mic is functioning now.
Yeah, I changed to my phone because my computer don't know why I cannot use the mic and the chat.
Oh, I see. Okay. Ayo, mosquito. What a shame. Okay, now over here, let's say if we use Sopor method. Sopor method is sum of roots and product of roots. Hasil tambah, hasil darab. Yeah? So SOR will be, you just take -5 plus 4/3. You use calculator. What do you get? What do you get? -11/3. Then over here, -5 times 4/3. Then we will have -20/3. 1 mark here, 1 mark here. And then x squared minus sum of root x plus product of root equals to 0. Then only you get another marks. Not yet. This one no marks yet. So put in your sum of root. Always minus, this one. So -11/3. The product of roots -20/3. Now we will have negative x squared plus 11/3x minus 20/3 equals to 0. multiply both sides with 3. So we will have 3x squared plus 11x minus 20 equals to 0. So this one, you got 1 mark here. Okay? You find SOR, you find POR, you got the marks, and you put in, this one they don't count, because if you put this correctly, at the end you also get it right. So you only get 1 marks here, and then 1 marks here, and 1 marks here. So both way also can. Understand? This one using the reverse of solving quadratic equation method. This one is using the SOPOR method. Okay?
So teacher, for the left hand side one, what if we use HTP, hasil tambah punca?
Hasil tambah punca is this one.
Oh.
Hasil tambah
This
punca.
is in English.
Hasil tambah punca is sum of roots. Then hasil darab.
No, I mean for the left hand side one. For the left hand side, use hasil tambah hasil
one,
darab punca.
if you use the sum of root and product root, it will be this on the right hand side. The left hand side is the other method. How do you use hasil tambah? No, cannot. No, cannot.
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 Okay.
I mean, they are two independent methods. So you will not see shadow of each other on each other.
Oh, that means
They're
the
two
left hand
different
side is not hasil darab punca.
It's not. It's an expansion. It's an expansion of your factor. This is your factor.
Oh,
This is
okay.
your roots, and then you put it back in, then this one will be your factor. So your factors, you multiply, you expand your factors, then you get this. So it works on the factors. Okay, you know what's factors, right? Factors is the result of multiplying to get another one. Whereby this one, you work solely on the roots. This one, you take the roots and work out for the factors. So this one on the roots, get the roots and then put into this general x squared minus sum of root x plus product of roots. Must remember, there must be an equal 0 at the back. A lot of students, they forgot to put 0 equals 0. They just leave their answer like this. This is not equation. This is just an expression. Equation must have equal sign. Understand? Yeah? For those who never put equals to 0, they don't get marks. They will be wondering, how come I got the answer but it's not right? Yeah, you are almost there. You're almost there only. Okay, so this is number 6. Okay, let's move on to 7. Okay, number 7, quadratic equation again. So now we have a quadratic equation, h and k are constant. It has 2 equal roots. Okay, whatever they say over here, we don't care. You just look for the keywords. It has 2 equal roots. Therefore, b squared minus 4ac equals to 0. In order for us to use b squared minus 4ac, the equation given must be written in the general form, which is ax squared plus bx plus c equals to 0. Okay, so your thinking pattern must be in this way. When you focus on express h in terms of k, I tell you, student will try to factorize your quadratic equation. It will go nowhere. So let's expand this first. So we will have x over 3 times 6x. So we will have 2x squared plus 5x over 3 equals to 3h minus 2k. And then we, write in ax squared plus bx plus c form, yeah? 2x squared plus 5 over 3x minus 3h plus 2k equals to 0. So identify our A, B, and C. This is the C. Okay, so let's put into b squared minus 4ac equals to 0.
Teacher, for
Yes?
2 equal root, then it's equals to 0. Then just now
Correct.
the one is, why is it more than 0?
Okay, greater than 0 is because it has 2 distinct roots.
Distinct root means?
Distinct means they are different. Distinct means different.
Okay, then the one lesser than 0?
Lesser than 0, no roots.
Oh, no roots. Okay.
No roots. Okay. Right, so for this one, b squared minus 4ac greater than 0, yeah? But when it say has roots, but it never tell you what kind of roots, yeah? Then you write b squared minus 4ac greater or equal 0. It could be 2 equal roots, it could be 2 distinct roots.
Okay.
Understand?
Okay.
Then no roots, it will be b squared minus 4ac less than 0. Okay, now next, just put b squared minus 4ac equals to 0. The b will be 5 over 3. Square it, minus 4. A is 2. C is this whole thing. So normally we put the positive in front, negative at the back, equals to 0. This one, 25 over 9 minus 8 times 2k minus 3h equals to 0. I want to make h the subject. Open up the bracket lah, if that's the case. Open up the bracket right away. It will be negative 8k plus 24h, right? This is 8. Sorry, 16. 4ac. 16k 24h, right? Then we make h the subject. So leave the h on the left hand side, the rest bring over to the right hand side. We will have 16k minus 25 over 9. And everything divided by 24, we will have h equals to 16k over 24 minus 25 over 9 times 24. New times. One six. This one simplify. So we will have 2 over 3k minus 25 over 216. That's it. Okay? That's the answer. Any question?
No.
No.
Okay. Now let's move on. Number 8. Find the range. Okay, this one very straightforward. It is just inequality. Okay? Now, so expand first. Always, when you see bracket, always expand first. So we will have x squared minus 2x greater or equal 8. Bring it over there because it's the quadratic form. When it is quadratic form, the one thing that we need to know, always write ax squared plus bx plus c together. All right, whether it is equation or inequality. So we will have x squared minus 2x minus 8 greater or equal 0. And then factorize, always factorize. Once you reach here, always use the curve. So when we factorize, to get 8, we have 4 and 2, negative and positive. Double check, the inner pair and the outer pair will give us negative 2x. Okay, right. Then we have to think if this is equals to 0, then on the x-axis, all right, we will have x equals to negative 2 or x equals to 4. But that is not what we want. We want inequality, greater than 0. Greater than 0 is all this. Because all the y value are above the x-axis. When it is above x-axis, it is always y positive. So therefore, when we answer, when we shade 2 parts, our answer also come in 2 parts. That means your variable is x. So x will be less than negative 2. Oh, equal. So must equal also. Or x greater than 4. That's the answer. Okay?
Yeah.
Easy? Next,
Then for this one have to see which to see is it lesser than and equals to or greater than equals to, we have to use common sense on this one. No specific thing to
we have
check,
to
right?
use this curve. We have to use this curve. Not common sense. I use this curve.
Oh, so we have to draw the curve.
Yes, once you reach here, now if this is x squared minus 2x minus 8 equals to 0, let's say, normally we will factorize, okay, then we will get our answer straight away, x equals to -2 or 4, right? This is when it is in equation. But if this is in inequality, okay, whether it is greater or less than, now let's say I use less than. Once I reach here, I cannot use this one to answer. I cannot just do like that and answer, no way. I have to write until this step. I have to write till this step. This one, okay? Cannot answer like this. Before I answer, I need to draw the curve, okay? Because this one is as good as your y. You want to get y less than 0. On x-axis, y equals to 0. Y less than 0 is below. Above is greater. Understand? So the turning point, the factor will be -2 and 4. So since we want everything less than 0, so less than 0 is here, because all the y value here are below the x-axis. If there is the y-axis here, this is 0, all these are -1. -1, -2, -3. +1, +2, +3. So everything above, positive. Anything below is negative. So we shape this one. Since we shape one part, the answer also come in one part, like this. Okay, one part, the answer will be this way. Small number on the left, big number on the right. Therefore, your arrow is always small on the left, the big mouth pointing at the right. But when it is greater, you shape this part. Therefore, you will have x go this way, -2, and go this way. You see the arrow is actually the same. Just that you have another equation sign there, so you also follow. Okay?
Oh, the greater than 0 is the y.
Greater than 0, yes. This whole thing is the y. This whole thing is y.
Oh, because, oh, okay.
So everything is on top. Because we want it to get y. Okay? Any other question? Clear, yeah?
No, yeah, clear.
Yeah, okay. So next, number 9. Okay, this one 3 marks. 3 marks for you. There is a standard way to do this. This is the maximum and minimum graph using the complete square format. Do you know the function of completing the square? The only function of completing the square is for us to find the maximum or minimum point. That is the only function we complete the square. I saw a big mosquito, I want to kill it. Otherwise, keep coming and sting on me. Okay. Now, right. So for this one, first, when you have this, you look at this. Your a is positive. Do you remember? Generally, it is like this: x plus p squared plus q. When your a is positive, you have a smiling face. When your a is negative, you have a sad face. So by looking at the function given, okay, by looking at the function given, your a is positive, so you got a smiling face. All right. So from, remember this, you start by from the function given. Okay, we have smiling face, therefore we got minimum point. So from function, minimum point will be, now minimum point will always come in x coordinates and y coordinates. X coordinates come inside here. So when x minus r equals to 0, your x coordinates is r. And your y coordinates will be the constant outside, which is 4. Never mind about the r. Don't compare right away here. Okay, don't. You just derive your maximum or minimum point from function first. Next, from graph. So from graph, obviously, minimum point can be found, but how? I know that quadratic graph, okay, symmetrical, because they will fall at the minimum or maximum point, and then the distance from the axis of symmetry will be equal. So what we need is, we can find the x coordinates. Isn't it the x coordinates can be found by taking 2 plus 4 divided by 2? But the y, I don't know, but never mind, just leave it there. So let's continue. 6 divided by 2 got 3, so 3y. So from the graph, we got our minimum point to be 3y. And then we compare like this. We put them side by side and then we compare. We got the r right away. So r equals to 3, 1 mark. And the equation of the axis of symmetry, which is this. This is our axis of symmetry. Since it's equation, we have to write the x equals to 3. That's it. You don't give me 3, 3 is not an equation. 3 is just a constant. Equation must have something, a variable equals to a number. That is called equation. And then we need to find the coordinates of the minimum point. It's actually here. The coordinate of minimum point. So minimum point. The x coordinates is 3. The y coordinates come from here because they are the same. 4. That's it. Found the answer. Any question?
No.
Easier. So to solve this question, free 3 marks for you. Identify your maximum or minimum point from your function given. Then identify your maximum minimum point from the graph given. Then only you compare. A lot of students, they try to fit in the r into the graph like that. Then they will make a lot of careless mistakes. So don't confuse yourself. Do step by step. Just 3 steps. From function, from graph, compare, you got the answer for all 3. You see, I just do this 2 steps. I already got the answer for all 3 parts. After all, 3 marks.
Teacher, this formula is called vertex form, right?
Yes, this is a vertex form. This is a vertex form. It will tell us the peak, the vertex, the highest point or the lowest point. Sometimes the question don't use find, they use state. That is why state, right? You just give the answer without any working. So not much working for this question. Okay? All right, so let's move on. This is number 9. Yeah, see, I'm very scared to touch it. Once I touch it, see? Once I touch it, it got hang. Okay. Easier to scroll. All right, number 9 done. So we go to number 10. Okay, number 10. All right, so we have y equals to x squared plus 2hx plus 6h has the minimum value. So we need to find this. Okay, whenever you see minimum value, maximum value, always complete the square to get the vertex form. Understand? So you must know how to complete the square. So how?
Take out the x.
Okay. What take out x? Like this. Just look at the terms that contain the x. All right, and then your x squared is already 1 as coefficient. So we shall do this framework. Square minus the square of the second term. Now leave the constant alone. Leave it alone. Hey, wait. Actually, yes, leave it alone. Plus 6h. And let me write one more time. Y equals to x squared plus 2hx plus 6h. This one will go through the transformation. Okay, complete the square. First term divided by x. The second term divided by 2x, you're left with h. And always minus the square of the second term, which is h squared. Then only we open up the square bracket. X plus h squared minus h squared plus 6h. So from here, this is in the vertex form.
Why hx?
Yeah, which one?
YHX minus HX squared.
Minus h squared. Why is it minus h squared?
Yeah.
Okay, because if you expand this one, okay, when we work backwards, when you expand this one, you have x squared plus 2 times x times h, 2hx. You always have an extra of h squared.
Oh,
That's why we'll have to always minus the constant. That is why when we work backwards, the first one I always divided by x. The second one I always divided by 2x because I want to get this. I divide by 2 divided by x so that I can get this number. And then this one will give us the terms contain x and also extra of constant. So always minus the constant away. Is that okay?
Yeah.
So this is already in the vertex form, and we know that the constant part will give us the y minimum. So y minimum equals to negative h squared plus 6h, which is also equals to 9. So, which is also, right here. So, yeah, 9 equals to negative h squared plus 6h. And rearrange, you see the square? Quadratic equation. H squared minus 6h plus 9 equals to 0. And factorize. Factorize equals to 0. 9, 9, 9, 9, 3 and 3. Negative, negative become positive. Yeah. Okay, therefore h equals to 3. That's the answer. Find a possible value, not values. So that will tell us how many h we have.
So why
So
did we use 9 equals to negative h squared plus?
Because it's
6?
given here. It's given here. The minimum value of 9. The y has a minimum value of 9. So the y minimum.
The minimum value depends on the q.
Minimum value depends on the q. We got q. This is 9.
I mean the
depends on the constant part.
the constant part.
In the vertex form, right? Y equals to a x plus p squared plus q. This is your y coordinates. This is your x coordinates.
Oh.
Okay? Your y minimum will be, yes.
At the first part, where did the plus h squared come from?
You see, this is given. This is given. The whole thing is x squared plus 2hx plus 6h. When I am using the completing square method, I never involve the constant because it actually will not affect our vertex form. Our vertex form is influenced by the terms that contain x only. So no point we bring in the 6h. If you want to bring in a 6h and then you add together with the h squared, you open it up, you still get your 6h. Again, understand? A lot of students, they don't see.
Minimum value always always y value.
Yes, always y value. When we say minimum value, it's always refer to y. Unless they say finding the corresponding x value. That means corresponding x value, that will be the x coordinates. Is that okay?
Yeah.
Now, a lot of time when you complete the square, all these are numbers. So you involve the number in, the number can add together with your square, your negative square of your second term. So you don't see the actual thing that happened. The actual thing that happened is nothing happened to the 6h. So no point we bring in and make your process so complicated. So always leave your constant alone outside. The one that contribute to the vertex form is only the term with the x only. Okay? So done with A. Can we proceed with B? Now for B, sketch the graph using the value of h given. So let's rewrite the whole thing. So y equals to, based on this, x plus h squared. And then you say minimum value of 9, so plus 9. Because if you put the h squared in, you have negative 9 plus 18, so you got positive 9. So this is the actual graph. We're going to sketch this graph. So over here, we know we have the minimum point. The minimum point is -3 and 9. And it is a smiling face because your x squared is having positive as coefficient. So let's sketch the graph like this, whereby your minimum point is -3, 9. Okay, -3, 9, so it will be like this.
So teacher, this equation only have one root lah.
No root at all, because -3 is here. Your 9 is there. Where will you cut at x-axis? No, so you will not get the value at x-axis. However, we need to show the minimum point as well as our y-intercept. So how do I find y-intercept? Use this one.
Okay, the minimum point not 3,9 meh? Why -3,9?
-3,9. Where got 3,9? Because your h is 3.
Then?
So x plus 3. So you let
x plus 3 equals 0.
Yeah.
Okay.
That's how you get -3. Okay, careful, yeah. Now, and then our y-intercept will be, always use this one, easy, because we know that x is 0. On y-axis, x is 0, so you're left with 6h. H is 3, 6h is 18, so we know that this is 18. So the sketching part, you see 4 marks over here. Wait, 4 marks over here, 1 mark go to your h value, 3 marks, 1 mark for your minimum point, 1 mark for your 18, another mark for the right curve. Okay, the curve correct. Okay, and then minimum 3, -3, 9 correct, 1 mark, and then another mark will be the y-intercept. Three marks plus 1 h value. Okay, 4 marks for A and B. Clear? Are you clear? That's why in this
We got the y-intercept from the y equals to x plus 2h, x plus 6h. Then we take the 6h times 6 times 3.
Yes. Do you know why I use this one? You want to use this also can. You want to use this x plus 3 squared plus 9 also can, because at y-axis, we know that x equals to 0. Therefore, y equals to 0 plus 3 squared and then plus 9. So this one is 9. 9 plus 9, 18.
Okay.
But the calculation process, for me, I feel that it's a bit too long. So I will always choose y equals to x squared plus 2hx. I don't even bother to find out what is the h when I use this one. I mean, when I want to use this, I don't have to change to x squared plus 6x plus 6h. I don't change it first, because as long as I see the x, 0 already. I just spend my time, go and take 6 times h only. You understand? So from the vertex form, we can find the minimum or maximum point. So we use this. Once we want to find y-intercept, always use this, because at y-axis, x equals to 0. So all the terms with x will automatically turn into 0. Easy calculation, no need to count like this. Lazy people choose this one. Okay? Clear?
Clear.
Now that is why under this question, you will see this question a lot. They ask you to sketch. Always first step, find extreme point. Extreme point means you've got to find your either maximum or minimum point. Second, find y-intercept. Always find y-intercept first. Why? From the y-intercept, you will know whether, from the minimum point and the y-intercept, you will know whether it will cut at x-axis. Then only finally you find your x-intercept, because sometimes x-intercept doesn't exist. Like in this case, you do not need to find the x-intercept. It does not exist. Okay? Next, number 11. So the function part already done. Now the linear equation part, which is, I haven't seen that, but normally they will ask in paper 2 because that one need a longer working. The 3 equation, and you need to solve them. Now let's look at the log question. Log base 3, log base 9. Always check when you want to do the log question or indices question. must check whether they have the same base. If not, we're going to change them to the same base. So in this case, we have base 3 here, base 9 here. So the only way we need to do is change to base 9. Okay? So I will change this one to base 9, the second one. So log base 3 of p minus, do you know how to change base? Just introduce the new base onto the object. And then we divide the new base onto the old base. Now, old base is actually 3 squared equals to 3. Just leave it like this. And then this one.
Wait, what?
Yes. Change base. This one is the process to change base. So log base A of B. If I want to change to base C, I want to introduce the log base C. This is base A. I want to change to base C. What do? I just introduce log base C of B. This one can't change away. Then we divide by log base C onto the original base A. This is the formula to change the, change the base. Is that okay? Right. So this is what I did. I want everything to be in base 3. So I introduced base 3 of Q over base 3 of 9. And because I know the relationship between 9 and base 3, 9 is actually 3 squared. So I write like this. And then remember the law of indices. When you have log base A of A equals to 1. Base A, base X of, what? Base X of what? M. To the power R. Then bring the R to the front. R log base X of M. Do you know this? So this one, same thing. I just bring this to the front. So I will have log base 3 of P minus, now the rest don't touch yet, just copy, do one thing at a time. This one I bring to the front. And log 3 is actually 1. We know that log base A onto A is actually 1. Remember this. This is the identity. Must remember. So equals to 3. Okay. Next. You see fraction? Don't like fraction. Don't you ever like fraction. That's why whenever you see fraction, always try to change it, okay, to get rid of the fraction mode. So we multiply both sides with 2. This is how we change, do away the fraction mode. So we will have 2 log base 3 of P minus log base 3 of Q equals to 6. Now what to do with this? Now if I can bring the index to the front, I can also do likewise. Do the other way around. So I can put this 2 back up like this. So I will have log base 3 of P squared minus log base 3 of Q equals to 6. Next. Remember the law of logarithm, log base A of X over Y equals to log base A of X minus log base A of Y. Another one is log onto the product. If it is onto the product, I must put a bracket here so that you remember. We have log onto the product, log onto the quotient. Log onto the product, we can split them up and add them together. Log base A of X plus log base A of Y. So which one am I using? I'm using this. If they give us the left, we give them the right. If they give us the right side, we give them the left side. So now we have this form. We've got to change it back. When it's minus, the subject need to be divided. So we will have log base 3 combine the P squared with Q by writing them in a quotient form equals to 6. Make P the subject. So therefore, you want to change the log base 3 away. Okay, we want to change the log base 3 away. The base of the log, now we know the log and index, they are cousin to each other. So if you want to change the log to the other side, it becomes index. Index form will come in this pattern. So the base of the log will become the base of the index. What happened to the 6 here? It becomes the index itself. Therefore, P squared will equal to 3 to the power of 6 times Q. Our objective is to find P. So P will equals to, you square root here, or basically both sides you raise up to the power of half. This is actually what happened. Therefore, you get P on this side. Over here, you have 3 to the power of 3, and then third Q. Okay, that will be 27 third Q. That is the answer. Okay?
Okay.
Any question from anybody that you're a bit confused here? The step is actually very easy, isn't it? We keep applying the law of indices.
But to remember the law lah.
Yes, this one. And always remember to give us the left, you give them the right. Okay? Now, next will be the index question. The index and the logarithm always come together. And this one I can erase because I need space. Never mind, I changed the color of the pen. All right. Now we've got to solve this one. Again, always check, do we have the same base? And if not, can we change to the same base? So we have base 7 and base 49. Isn't it? 49 also can be written in base 7. So change that. So this one, just leave it first. 7 to the power of x squared minus 49 is actually 7 to the power of 2 raised up to the power of 6 minus 2x equals to 0, yeah? Okay, since it equals to 0, now we can do like this. Bring this one to the other side. So we have 7 to the power of x squared equals to 7 to the power of 12 minus 4x. Single term equals to single term. Therefore, their index must be equal. Isn't it very easy? This question is so easy. Right.
So 2x equals to 12 minus 4x.
Yeah, x squared equals to 12 minus 4x. You see, quadratic form. So the next thing will be quadratic equation. So x squared plus 4x minus 12 equals to 0. And factorize. X and x, 6 and 2, I guess. Negative here, positive there. Double check, huh? X squared. 6 and negative 2, negative 12. The inner pair, negative 6x. The outer pair is negative 2x. The sum will be positive 4x. Okay, correct. Okay, once it is correct, then we can give the answer already. X equals to negative 6 or 2. Yep, that's all. Okay, so what do they want to see will be 3 marks. How do we get the 3 marks? Of course, the answer consider 1 mark. And this one, 1 mark. And then you write this one, the 7 squared. This one, another mark. So 3 marks altogether. Okay? Easy. Always check the logarithm and index question. Always check, do they have the same base? Try to make sure they are in the same base. Then only we can start solving. Okay, next, this one. Are you copying? Am I too fast? You can copy in time, right?
Can.
Now next, okay, this one we have 1 term, 2 terms, and 3 terms. And just check, do they have the same base for the log? Yes, log base b, log base b, log base b. Okay, great. When we have that, you see the coefficient in front, always bring up. Coefficient in front, bring up. Okay, so we will have log base b of 3 to the power of 5 plus log base b of 5 to the power of 3 minus log base b of 72 equals to 3. Same log base b, when it is plus, the subject need to be multiplied, and when it is minus, its subject need to be divided. So we will have log base b 3 to the power of 5 times 5 to the power of 3 divided by 72 equals to 3. This one, use calculator to simplify. Can you? 72 is actually 3 to the power of 4, is it? Okay, no. We cannot. 72 is 36 times 2. 36. 66. Oh, cannot. Don't want to touch it. Okay, can you try? To solve means we need to find b. Huh? Can you use calculator and calculate this one? 3 to the power 5 times 5 to the power 3. Where's my calculator? Zaggy, take my purple bag here for me, please. Hurry. Huh? Go and find my purple bag. My purple handbag. Yeah.
30,375.
Hey, wait. Hey, your answer? Waiting for your answer. Hey.
30,375.
Wow. Such a big number. Can you write for me?
After you log or before you log it?
Huh?
No, teacher asked for 3 power 5 times 5
3 to the power 5.
3.
You can't log it because log base b, there is no value for your b. How do you find the log base b?
30375, right?
Your objective is to find what is b. So 3 to the power 5 times 5 to the power 3. Okay, wow, such a big number. Cannot be like. Okay, never mind. I'm very lazy to write such a big number. 30375. Oh, can we simplify it by 72 right away?
421.875.
75 divided by 72. Oh, cannot. We don't want fraction, yeah? And we don't want decimal number, preferably in fraction, so that we can simplify it later. 72. Here. I don't like this number. Okay, the simplest form will be this. Okay, we have log base b, and then 3375 over 8 equals to 3. Next, we want to find b, right? Change the log base b across to the other side. The base of the log will now become the base of the index, b to the power of 3. So let's rewrite this one in terms to the power of 3. We know 8 is 2 to the power of 3. What about 3375? 3375. Wait, square root of, cube root. 3375.
15.
15.
Yes. Found the answer right way. Therefore, b equals to 15 over 2. That's it. Now, always leave our answer or whatever form in fraction. Don't put it in decimal. No. Decimal will not give you a better view on your answer. You understand? Always put in fraction. Because if you put in decimal, you will not see that 8 is actually can be written in 2 to the power 3. If 8 can be written in 2 to the power 3, the 3375 most likely can also be written in some number to the power of 3. Understand? Okay, so that's it. Found the answer. Easy? You must start right lah. You start it right, then you get the answer easily. Any question?
No.
No. Super easy, right? Let's see. Okay, this one will be our last question, right? The rest you try on your. I already uploaded this in your Google Classroom. You can continue from there. Okay, last question. Now over here, 3 and 729. Okay, what is the relationship between 729 and 3? 729 can be written in the base of 3. So let's do that.
9
this one
base
just
3.
copy first.
9 to the power 3.
Log base 4 of x. This one is 3 to the power of what? 9 to the power of 3. 3 to the power of 6. Yeah. Or 9. 3 to the power of 9, sorry.
Yeah.
Right? Okay, 3 to the power of 9. That means, you see, single term equals to single term. The index must be equal. So therefore, log base 4 of x
not
equals to
3
9.
power 9.
Not 3 to the power of 9. Then what is that?
It's 9 power 3.
Oh, 9 to the power of 3. But 9 is, then 6. 6. 3 to the power of 6. 3 to the power of 6. because 9 is actually 3 squared and the power 3 remain. So you're 3 to the power 6. Yeah. Okay. Oh, hang. Right. So therefore,
I don't understand the first line.
this one,
The 3 to the power of log base 4x.
3 to the power log base 4 of x, equals to, this one just copy exactly. Copy exactly, because we can't do anything. So we copy exactly, but we can do something on 729. We can change it in a form of index. So we can write it in 3 to the power 6.
Oh, we want the base to be the same only.
Yes. Whenever you see index question and logarithm question, always make sure the base is equal. If the base is not equal, then we have to introduce a log base 10.
So once the
it's
base
like
is
this.
equal, we can discard it lah.
Yes, correct. We can compare it single term with single term. So the left side must be equals to the right side. So we will have log base 4 of x equals to 6. You want to find x, isn't it? So I just move this log base 4 across to the other side. So the base of the log will now become the base of the index. So x equals to 4 to the power 6. Just use calculator and give the answer. 212 1024 2048. Is it 4 to the power 6? Hey, no. 4096.
096.
Yeah, 4096. Yep. Okay. Easy. Actually, index and logarithm very easy. First thing, make sure they have the same base. What if they are not in the same base? For example, 2 to the power x equals to 5 to the power of x. How do you do this? You can't change to the same base. In this case, we introduce log base 10 on both sides. Therefore, we will have, now log base 10 is actually LG, okay? I'm lazy to write log 10. Just write LG. 2 to the power x equals to log 5 to the power x, and then apply the law of logarithm, the third one, bring down the x to the front. Log 2, you use the calculator. Log 2 is 0.3010. So we will have 0.3010x equals to, the log 5 will be 0.699x. Of course, the question not that simple like this lah, because
So
like
log base 10 is the one that we have in the calculator.
yes, that's why we introduce log base 10. Don't introduce other stuff. You don't introduce log base 2.
Okay.
Okay.
Then we just compare.
Yes. Compare. No, you. I mean, this one I create out of nowhere. So my question itself is not logic here. So there must be something like probably like +2 or something like that, so that you will have +2. Let's say, let's say you have a +2, then you will have 0.699x plus 1.4 something 398 maybe. Okay. Then you bring this together. Okay, so 0.3010x minus 0.699x equals to 1.398. Find the x and then rearrange everything. Okay?
Okay.
That's it for our class today. Is it time's up yet? Yep, just nice. Wow, we are quite productive today. 14 questions.
Yes.
Right. Yes, okay. But it is only, which chapter? This one?
Chapter 4.
Chapter 4. Okay lah. Still not bad. So next class, maybe we can continue. I have another set of paper full of high order thinking questions, but then I do this one first.
Yeah.
Oh yeah. You want me to upload that one? Do you think you can finish this in this week?
Not sure.
Okay. Do your best lah. Okay. All right. Thank you, everybody. All right. We just end our class here.
Thank you, Ja. Bye, Ja.
Yeah. Take care. Bye.